Hello, everyone. My name is Rickabaugh. I've been on the Angular team for about 7 years now. Worked on a number of things, but currently I'm the tech lead of the Angular framework team.
And my name is Jeremy Elbourn. I am the tech lead of the Angular platform, and I've been on the team since 2015, and I've been involved with Angular and Angular JS for about 10 years.
So welcome to our talk, Angular, a design review 10 years later.
And you may be wondering, why do we want to do a design review 10 years later? And I will emphasize, it is 10 years later, not 10 years late, that R is important.
Yeah, and it turns out it's actually a great time to do this.
Yeah, it's actually just over 10 years since the 1.0.0 release of Angular JS came out on June 13th, 2012. And in that 10 years, we have gotten quite a bit of a community engagement. We've gotten feedback from people at conferences and in person, and we have closed over 30,000 GitHub issues between AngularJS and Angular.
Let's go!
And the web has not stayed static in that decade either.
Yeah, so this slide is just the things I could list off the top of my head without looking anything up about really significant things that have changed in the web platform that impact the way we all write and build and deploy web applications.
And so we're really in a very privileged position to be able to do something like this. There aren't many projects in the web ecosystem that are still around after 10 years, right? That have all of this feedback.
Yeah, it's you who are all still showing up for ng-conf and not YUI-conf. So Angular is always evolving, right? That is also part of this.
You mean this web framework thing is not a solved problem?
Yeah, people keep creating new ones, so apparently not. So, it's important for us to retrospect and do some introspection on the design decisions that went into Angular and continue to evolving and improving things over time. Now, we do prioritize stability on Angular, right? We have things like ng-update, our LTS policy and deprecation policy. But stable is not the same as stagnant, right? You've seen over the course of this event already that we are working on big changes to Angular, things like standalone components, the directive composition API that you saw hinted to in the keynote, and the inject function that everyone seems to love.
Yeah, we're in this for the long haul. And if we look back and see that some of the trade-offs that we made in 2012 and 2015 are no longer serving us as well as they could be, right? We want to be able to think about those things. So we're going to talk about 5 different aspects of Angular today. Those would be automatic and global change detection, our unidirectional data flow, our use of selector-based APIs for components, Rxjs, and the fact that we embrace compilation.
And on each of these topics, in the time that we have, we are going to dig into what is the topic we just talked about in the previous slide. What were the design choices that went into that aspect of Angular? What were the outcomes of those choices, the consequences of those outcomes? And what are our takeaways today, 10 years in the future from that launch of Angular JS?
So let's start with something very fundamental to the Angular that we know and love, and that is our automatic and global change detection.
So the key design decision that went into how Angular's change detection works is this idea that your view state can live anywhere. And not just live anywhere, but that your state is mutable anywhere. Right? Anywhere on the globe, your state can live in the middle of the Pacific Ocean there. And you have no wrappers, no getters and setters, and no APIs you need to remember to call. No $apply, no $digest, no render. So you can have a template like this, where you've got user, profile, biography, deeply nested object. You can have state inside of an array, and you can mutate that state deeply inside of that object. You can add and remove items from this array. You can mutate items inside of that array. And again, you don't have to worry about it. It just works.
Yeah, and this is an amazing experience, right? This is kind of a unique thing to Angular. And it's one of the reasons that I fell in love with the framework when I started using it, even before I joined the team. But what we've seen in the feedback that we've collected over the years, right, is that sometimes this magical story of it just works has some caveats. There are some costs associated with this, particularly around performance and complexity, that weren't necessarily anticipated in the original design. So we talked about how your state can live anywhere, right? And you don't have to tell Angular necessarily what you're changing or when you're changing it. And so when Angular does change detection, it's kind of playing this game that we all did as children, right? Where you have two pictures and they're slightly different and you're trying to figure out what those subtle differences are. The eyes are one, if you're wondering.
Yeah, it took me a minute.
Yeah, and so Angular's going through this, right? It's looking at your state before and after. It's like, oh, what did they change? What do I need to update? And it's a little bit more complicated than that. Because we don't get a signal from you when you change state. So we have to have an answer for that too. And you might know our answer there is Zone.js. We've talked a little bit about this today. And if you've looked inside the Zone.js code, you probably kind of recoiled in horror. I did as well. But it's a dense library. But the concept actually fits here on a slide. I was kind of laughing because Michael had a very similar slide in his talk. But basically, Zone.js monkey patches these APIs in the browser that are responding to events in the application, and allows Angular to kind of hook in after the application does something in order to start this process of change detection and figure out what you changed, right? Compare the pictures of the owls. And so we monkey patch things like event listeners, set timeout, promise, XHR, basically any API in the browser that takes a callback. And that really allows us to have this kind of design that underpins change detection. On any browser event, Angular is going to kind of let the application do its thing, and then react afterwards and look to see what changed. And this has an immediate consequence, right? That Zone.js is a non-negotiable part of this equation. It's not the biggest library, but it's not small. It's like 16 kilobytes minified, about 50 for the browser to download and parse. And then that monkey patching isn't free either, right? Zone doesn't know what APIs your application is going to call. So it has to patch all of them, and that eats up kind of precious milliseconds in its critical application startup. And there's another thing here that you might spot, right? Which is that we don't know if your application made any changes at all, right? How often does something happen in the browser that doesn't change your model? And it turns out this is kind of frequent. You know, you might be computing intermediate state where you're not quite ready to show something. You might be waiting for multiple asynchronous things to happen. You may have event handlers that are only relevant in certain contexts. And so what we see is this automatic global change detection, while a nice experience for the developer, can be kind of inefficient. If Angular is doing a lot of work to only realize the application didn't actually change anything, right? The UI doesn't need to update. Another kind of problem that we see is when you have third-party scripts on the page, like advertising scripts or analytics or something. Those tend to create a lot of event listeners, a lot of timeouts. And if you innocently, accidentally initialize them in the context of your Angular application, that can result in a lot of change detection. So while we have this nice picture of you don't have to care where your state is or when it changes, when it comes to performance problems, sometimes you start having to care. Sometimes you start having to know about how Angular works under the hood. And so the final kind of takeaway here is that Zone.js, while it solves the problem nicely, right, it's not as transparent of a solution as it was originally designed to be.
So Zone.js is about half of Angular's change detection story. It tells you when things are going to get checked, but how do we actually do that checking? So say you have something like this in a template, some user biography. How does Angular know when this has changed and it needs to update the DOM? Well, there's a dirty little secret here, which is that it's just doing a not equals check, right? It keeps track of the old value, and when Zones triggers that something may have changed, it looks at that new value compared to the old value. If it's changed, update the DOM. AngularJS works this way, Angular works this way. And other web frameworks also have a not equals check, just like this, kind of buried somewhere in their internals. Vue, React, Svelte.
React calls it VDOM diffing.
Yeah. And AngularJS had kind of a problem with this, a digest problem. So AngularJS let you define watch expressions that you could give a callback, and in that callback, update some state when some other state changed, and that could lead to more state changes, and so on. And this could happen up to 10 times. And Angular made a lot of changes in order to try to prevent that from happening. But the number one biggest design choice that went into Angular to try to mitigate this performance problem was this. Change detection runs in DOM order, checking each expression exactly once. And we refer to this as unidirectional data flow. And you can kind of see this play out here in this example. We have an account settings component. We walk down from the root, checking everything in that component, down to the next components, down to the leaves. And what the unidirectional part of this means is that here in the user profile component, while this is being checked, we can go ahead and read state from account settings. That's totally fine. But if we try to mutate state in account settings, then we're going to have a problem.
But it's OK, right? Because Angular prevents us from doing this in the first place.
Well, you could certainly inject one of your ancestor components and then mutate its state in ng-on-changes. You could mutate your own component state in ng after view checked, or you could grab some content children and mutate their state after they have been checked in ng after content checked.
And if you've done this in your own code, you probably know what happens next. What is it?
Yes, so we've gotten quite a lot of GitHub issues about everybody's favorite ever, expression changed after it has been checked. At least it's grammatically correct. And we see this all the time on Stack Overflow. One poor soul has even gone to Quora for help with their expression changed after checked error. And we, as you saw in the keynote, have a very fancy error page for explaining what this is and how you can fix it.
Fix it? You mean like set timeout?
So how many of you in the audience, how many of you,
raise your hands, how many have done this?
Have worked around this problem by putting a set timeout in your code, calling it a day? How many of you have gotten a little bit fancier and done a promise.resolve.then so that you've got a micro task instead of a macro task because you're sophisticated?
All right, raise your hand if you think this is a hack.
Yeah, if you think this is hacky, right? If you think this is something you're not supposed to do, raise your hands. Yeah, that's quite a lot of people. So our big takeaway here is that unidirectional data flow is actually pretty hard for developers to stick to and to internalize.
Yeah, we can have really nice videos that explain where the error comes from and kind of how to deal with it. But at the end of the day, the signal that we're getting, looking at our issue tracker, looking at the feedback we get, is that this is something that's happening to developers fairly often. And so does Angular just need more guardrails here?
Well, as we saw in the examples before, it certainly doesn't do a lot to help prevent you make these mistakes in the first place, but there's actually more to it than that. Let's take a look at a very common UI interaction pattern, forms validation. I'm sure most of you in the audience have done some sort of forms validation before, and here is a case where inherently the validity state of the form is derived from the validity state of its child controls, right? This is a very common pattern that is not just in forms validation, but also in a lot of common UI controls, like list boxes or menus. Developers run into this all the time. And let's go back to that design choice we looked at earlier, right? This bold part here, change detection runs in DOM order. This is based on an assumption that the hierarchy of your data in your application can follow that DOM order. And we can see in these examples that
it's backwards.
Yeah, this doesn't always hold true, right? There are common scenarios in real-life applications that don't really mesh well with this assumption.
But Jeremy, Angular has a forms module, right?
Well,
we have a form system. We should
Yeah.
just do what forms does to solve this problem.
So let's take a look at the implementation details, literally copied and pasted from ng-form.
It's a promise resolve.
Yes.
Womp womp.
I actually even fixed a bug when I went to pull this code for the slide. It had null there, and it was not necessary. And this is a sign that there really is a real need for this kind of update, and that Angular isn't really providing a great way to do it today. Like, you don't actually have an alternative than doing something like this. And that brings us to kind of our second takeaway here we got into is like the hierarchy of data does not always match the DOM hierarchy, and there are real scenarios where that matters.
Sometimes scheduling and other change detection is what you need to do.
Yeah. So we also talked earlier about this idea that your state can live anywhere on the globe, no wrappers, no getters, setters, you can mutate it any way you want, and fundamentally, the idea being you don't have to worry about it, right? It just works. But all of this leads us to another takeaway, which is that requiring developers to understand this unidirectional data flow concept contradicts that it just works mentality, right? It undermines the idea that you don't have to worry about it, because you actually do have to worry about it. There are times and there are places where it is not okay to update your state, and rather than being some explicit API that you have to remember to use or to call, you have to remember this invisible, kind of confusing constraint about the lifecycle of the application.
So that's a lot of information about change detection. Let's shift gears a little bit and talk about template syntax, and in particular, our use of selectors in our component APIs. So early in the days of Angular JS even, right, we made this decision that we wanted to make templates look and feel like normal HTML.
Yeah, I love HTML.
Me too, right? And HTML is the language of the web. This makes some sense, right? We all have developer tools and IDEs and stuff installed to work with HTML. And we also kind of, in parallel with this choice, decided that we were going to use CSS selectors to apply components and directives to other elements.
So let's take a look at some code that shows this off, right? We've got Mac checkbox. It's got a selector here, element selector for Mac checkbox. Use that in your template, and boom, just feels like HTML, right? You could just walk right out of the W3C school, and this makes sense to you. But there's an outcome to this choice, right? That all components have a host element with shared ownership with the user. So going back to that Mat checkbox, right? This Mat checkbox DOM element, as a real DOM element, is the host element for the component. And if we look at another example here, let's say we have a slider. The component author here is able to come in and add some ARIA attributes here, some classes, they can add event listeners, that are all details of that component's inner workings. And the user of this component can also come along, they put this mat slider in their template, and they get to add attributes and classes here, ARIA label, to that same DOM node. And in this case, this works really nicely because the component author gets to capture the things that belong on this element that relate to the internal implementation details, the internal behaviors of this component that component is responsible for. Whereas the user of this component, they come to this element and they apply the parts that they're responsible for. The ARIA label, any positioning classes, things like ARIA described by. Right? The component author, they have no way of knowing what those things are supposed to be. And this doesn't require any work. You have a host element and you get to just have both of these things coexist on the same element naturally. But it's not always such a good fit. Say we want to add some custom styles to this host element. Alex, what is a style attribute that's okay for me to put on this component?
Flex direction.
Ooh, hopefully not. There are definitely some CSS properties that are totally okay to set for these things and that are necessary to set. Things like margin and positioning, right? You need to be able to lay out this component in your page. But at the same time, if you start changing the CSS properties that render the internals of how that component renders, things like padding and box sizing, there's a very good chance you're going to mess up the way that component was implemented and the expectations it has about how it will render. And it's really tricky to navigate what you can and can't do on this element. And so that leads us to a couple of takeaways from this. One is that host elements do give you a very natural way for both external concerns and internal concerns for the components to coexist peacefully on the same element, when necessary, but at the same time, we have another takeaway that this shared ownership model makes it easy to accidentally disrupt the component's internals because you have two parties that are both able to manipulate the single DOM element.
Yeah, it kind of breaks encapsulation in a way.
Exactly. Now, we can also look at Angular components that use attribute selectors. So in this case, we have map_button. In real life, this does use an attribute selector. And here, you get to use a native HTML button element. You put a attribute on there. This feels very natural. It feels like just writing HTML. And this brings in additional behaviors and styles. It's not just buttons. We can do this on ULs, LIs, navs, anchors, and take advantage of. We talked about shared ownership earlier, right? It's not just shared ownership between the user of the component and the author. There's also ownership now of the browser itself is bringing some behaviors along for these things. And if you talk to any accessibility expert, one of the first things they'll tell you about building accessible applications is to use the appropriate native DOM elements when you can. And Angular selector-based approach gives you the power to do that, and that is a really nice outcome of this. You get a lot of flexibility in your API design by being able to take advantage of these selectors. You can even go further and do behavioral composition by using selectors like this. We can take a table component and add virtual scroll by encapsulating that into an attribute directive. And so you get this very natural API again by adding a table element and just putting a virtual scroll attribute on there. Again, very natural feeling, very HTML feeling. And you can even do this invisibly sometimes, right? Angular CDK has this dir directive that adds a directive every time you use the dir attribute for setting the right to left or left to right language context so the components can behave appropriately. But you would never even know that you're using that, right? And while this is powerful, it can be very surprising, right? It is actually very challenging to know the full set of behaviors that are applied on an element because you don't necessarily always know whether this attribute is a directive or is it just there for styling or for some other reason.
Yeah, and even Angular's compiler, right, has to be able to figure this out. So when we designed Angular, we decided that we wanted to have what we call scoped templates. And this is kind of an alternative to having some kind of like global component or directive registry like Angular JS did. We saw that with a custom elements API in the browser. We saw that with Angular JS where we're like having a single global registry was kind of causing some problems when different libraries would try to use the same name. And so Angular has to kind of be able to figure out which elements are allowed to be used in your template. And so you declare this to Angular through things like ng-modules, or through the fancy new standalone API. But this kind of leads to this outcome, right? That using a component is not a simple thing. It's not just adding the element to the template. You also have to kind of plumb this component through your ng-modules or through your imports. There can be some ceremony associated with this. And Angular can't always help you if you get it wrong. So in this example, if we don't import the map_button module, Angular has no way of knowing that this isn't just any other attribute on this DOM element that we're using to apply some styles, for example. And by the way, Jeremy, what happens if I forget map_button module?
Well, it doesn't look great. But you don't get any errors. You don't get any warnings when this happens. You just run your app and it doesn't look right. And this is really confusing for people who are new to Angular because they've followed exactly what the documentation says. They just forgot that extra import. So this brings us to our another big takeaway for this section, which is that selectors here, they inherently introduce an additional layer of indirection that can sometimes confuse and make it hard to reason about what is going on in your templates.
All right, so let's dive into one of our most kind of contentious topics of the list, which I would say is Rxjs.
And we say contentious because, we talked about earlier, we do these big annual developer surveys, and we get a solid chunk of developers, a solid % of the responses say, hey, I want less Rxjs in Angular. It's confusing. I don't need it. And we get approximately an equal number of responses that say, hey, I love Rxjs, and I would like you to integrate it more deeply.
So clearly, we have the perfect amount.
Yeah, we got it right in the center, so that must mean everything is perfect, right?
And so let's talk a little bit about the history here. So in the early days of Angular, we decided that we did not want to have some kind of blessed state management pattern. We think that different applications have different needs around state and how it's stored, and we don't think there's a one-size-fits-all solution here. One of the goals of automatic change detection is that you can bring whatever state management library you like. And that's actually working rather well in Angular today. So there are several different community projects, for example, that integrate Angular and Rxjs in various ways.
But wait a minute, Alex. Doesn't Angular use Rxjs internally?
Well, yes and no. It turns out that Angular does not actually build its reactivity system on top of Rxjs. When we're going through that flow of change detection, we're not using observables to convey information about inputs being set from parent to child components. Angular uses observable mainly as a convenient and composable primitive for expressing streams of events. And so if you look at the APIs in Angular that return observables to you, things like form control value changes or the HTTP client, they're really dealing with events, right? When the value changes, when the validity changes, when the zone becomes stable. They're not really leaning into this functional reactive design style for dealing with state. There are some exceptions there, but this tends to be the rule. But regardless of that, we know that in our community, right, using Rxjs for state management is a very popular pattern. So how do these two things work together, right? How well does this actually work in practice? And there are some problems here. One of the main ones is that at this boundary between Angular and Rxjs, it's kind of hard sometimes to get observable information from Angular.
I don't know,
example,
Alex. I don't think it's that complicated. All you have to do is create a behavior subject for every single input, and then in ng-on and init, you initialize that with all of their initial values, and then in ng-on changes, whenever they change, you have to, okay.
Yeah. And this doesn't even do all of it, right? There's no ng-on destroy here. We're not cleaning up after ourselves. This is going to leak memory. But there's a subtler problem here, which is even if you go through all the trouble of expressing your state flow in terms of Rxjs, what happens is you have great information about where your data dependencies are, right? What needs to update whenever a new piece of state comes in. But Angular's change detection is based around the idea that it knows nothing about where your data is or when you change it. And so these two things don't talk to each other. Even if you go through all the trouble of making all of your components on push, you're using the async pipe to convey your state, right? What happens is, yes, Angular knows that if your user observable didn't emit, then it doesn't need to check this part of the tree. But if your user observable does emit, it doesn't know that nothing else in your application that isn't subscribed to that observable needs to be checked, right? It's going to check it anyway. And making everything on push doesn't save you here, because when a component is marked for check, right, when the user observable emits and we know we need to check the profile, Angular still does change detection from the top. So it's going to mark everything all the way up to the root for check as well. So this is kind of more of that inefficiency that we're talking about, where you have good information about where your data dependencies are, which components need to be updated and which don't, but you're not able to really tell the framework about that. And so the main takeaway here is that there's some real barriers to building kind of these great state management experiences that unify Angular and Rxjs. And this is something we're looking at fixing. Not just for Rxjs, but for lots of these kind of new ideas that are floating around the web ecosystem right now in terms of reactivity. We want Angular to work really well with some of them. So our last topic of the day is compilation, right? The fact that in Angular we decided the compiler was going to be a core part of your development and your deployment workflow. And we did this because we saw in Angular JS that there was this inherent tension between the developer experience that we wanted to offer users in terms of APIs around making components and templates and things like that, and the code that needed to become in order to render efficiently in the browser. And so what Angular does is it takes the kind of developer experience on the left and compiles it ahead of time to this crazy code that needs to run in the browser on the right, and does that without any cost to the user, right? The user's not waiting for this to happen because it's already done before you deployed your application. So I don't know about you, but I would much rather write with templates and data binding than try to handcraft this thing on the right. And we think we actually nailed it here. Having a compiler allows the developer and the user experience of Angular to evolve independently. And we saw this most recently with Ivy, where we completely rewrote the renderer, but the developer experience didn't suffer, right? Didn't have to change. And another area that we think we kind of nailed it is with TypeScript, right? We built Angular on top of TypeScript. Yeah. This sounds obvious in 2022. Why would you not do this, right? But back in the early days, this was not a foregone conclusion. TypeScript was very new in the ecosystem. It did not have the adoption or the support that it has in tooling today, especially at Google. And we went through a number of iterations before we kind of landed on TypeScript as our language of choice. We even tried to make our own language. It was like AtScript.
Yeah, we're never going to talk about that one again.
Okay. Bad memories. But it turns out TypeScript is one of the things that people love the most about Angular. We get a lot of feedback about this. And it is also one of the things that we love as framework developers. TypeScript is a big reason why we've been able to move as fast as we have, both in terms of like writing our own code, as well as being able to migrate your code. But not all is amazing in compilation world. Early on, we decided that Angular would use something we call global compilation. And this means that our compiler would know everything about every component that you were using in your application, even those coming from libraries like material, and we'd feed all that information in and produce the whole application at once. And there are good reasons to do this. You can optimize a lot of things when you have perfect information about how things are used. But the reality is, this makes our compilation step kind of an expensive part of this process, right? You need a compiler that knows about a lot of things and has to read a lot of code in order to do its job. And the reality is just that it adds to the time it takes from when you save a file in the IDE to when you see that code running in a browser or a test. So compilation is one of Angular's biggest strengths, but it's also something that we're not done improving, right? We think we can do a little bit better here.
So that was a lot of topics to go through in, we're only 2 minutes over. And what are our bigger takeaways from looking at all of this, right? So if you only take one thing away from this talk, if you only learn one thing about software engineering, it's this. All design decisions have trade-offs. Now, a lot of design decisions have gone into Angular over its entire lifetime, and we have the benefit of being able to look back now and see how some of those design decisions have played out, and what some of those trade-offs have delivered to us, right? In terms of developer experience, in terms of performance and accessibility.
And how they've lived up to a changing web.
Exactly. And we are retrospecting on all of this because Angular is always evolving, right? We don't want to take any part of this and just say, like, well, that's the way it was designed and we'll just have to live with it forever, right? These are things that, even though they are fundamental to Angular's design, we still see them as room for improvement, right? They are still things that we can sit down and we can find ways to bring developers a better experience, to bring faster web applications to you. And it is going to fall in line with Angular's commitment to stability, right? We talked about earlier, right? We have our commitment to stability in terms of things like ng-update and the LTS policy. And everything we do in trying to address larger foundational points of friction in Angular like this is going to be in line with that commitment to stability.
Yeah, we're not here to announce Angular 3, right? There's not going to be an Angular next. This is going to happen as slow and steady progress over the next couple of years. And we wanted to give this talk today to kind of open the conversation, right? We're telling you some of the early things that we're starting to think about. What kinds of things might we want to fix? What kinds of problems are we seeing? And this will eventually filter down into kind of design proposals and then RFCs, right? Where we're engaged more directly with our community on, here's an idea. What do you think? How would this work for you? But we're happy to talk about this today. So if you find us in the hallway or somewhere else at the conference, feel free to come up, ask us. We're happy to talk about what we're thinking. We want you to be a part of this process.
Yes, and for those of you watching this talk later, be sure, Mark Thompson and I, we do a stream every month where we talk about Angular and play a game, so that's another good place for you to come and join the conversation on this. So thank you again, everybody, for coming to our talk, and we won't hold you from your dinner any longer.